All right, today we're diving into something pretty wild. We're going to explore an idea that connects an ancient, almost superstitious belief with, well, with some of the most mind-bending science out there. It's a connection that, honestly, you'd probably never see coming.
So, you've probably heard of the evil eye, right? It's this belief that's been around for thousands of years, all over the world. The idea that a jealous look or a nasty glare can actually cause bad luck or misfortune. It's a classic piece of folklore. But what if physics had something to say about it? I know, it sounds crazy. But the source material we're looking at today asks a really out-there question. Could the bizarre rules of the quantum world actually give us a modern way to understand this ancient belief?
Okay, so to even start to unpack this, we need to hit pause on the folklore for a second and jump into the deep end of quantum mechanics. Yeah, it's a huge leap, I get it, but trust me, this is exactly where the core of this whole theory comes from. All right, so down at the tiniest subatomic level, things get weird. A particle like an electron doesn't actually exist in one specific spot until we measure it. Before that, it's in what's called a wave function. Just think of it like a cloud of pure possibility. It's not here or there, it's kind of everywhere at once, spinning up and down. Literally, every possible outcome is happening simultaneously inside this cloud.
So how does that fuzzy cloud of maybe turn into the solid reality we all know? Well, that's something called the observer effect. The second an observer, let's say a scientist, tries to measure that particle, that whole cloud of possibilities just collapses. Instantly, it snaps into one single definite reality. The simple act of looking literally forces the universe to make a choice.
Okay, and this is where things get really, really wild. The theory we're exploring takes that quantum idea, the observer effect, and applies it to, well, to people, to you, to me. The source material makes this huge, bold leap from the tiny world of particles to the complex world of human lives.
Here's the central idea. What if a person's life is just like that wave function? Think about it. At any moment, your future isn't one set road. It's a massive cloud of possibilities. There's a version where you get the promotion, a version where you don't, versions where you trip on the sidewalk, good, bad, and everything in between. They're all just sitting there, coexisting as pure potential.
Okay, so if your life is this big cloud of possibilities, what makes it collapse into one single outcome? Well, this is where the theory stretches the definition of observation way beyond a science lab. It's not about a measuring tool. According to this idea, observing someone could be as simple as seeing them, hearing about what they're up to, or even just thinking about them. All that attention, all that focus acts as an observation.
And that right there leads to the big question. If one person's attention can be an observation, what happens when it's not just one person? What happens when it's thousands, millions? What happens when you're famous and all those eyes are on you?
The source has a really good way of explaining this. Imagine a big building. One security camera gives you just one view, right? Just one angle. But what if you have 100 cameras? Suddenly you see everything. The front, the back, the roof, the side alley. The building becomes more known. More of its reality is revealed. Well, the theory says fame is like adding 1,000,000 cameras to a person's life.
So now it all comes down to a numbers game. Let's say, just for example, that your life cloud has a 10% chance of a bad state happening. You know, getting sick, having an accident, something going wrong. Every single observation forces that cloud to collapse. It's like rolling a die. When you have millions of people observing you all the time, you're basically rolling that die again and again and again, thousands of times a second. Statistically, you're just way more likely to eventually land on one of those bad outcomes. Fame, from this perspective, is basically a mathematical risk.
But hold on, what about the people who completely defy this? You know, the ones who live under an insane public microscope and just keep winning.
Well, the source material actually tackles this, and it brings up a really interesting counterexample.
The theory brings up someone like Cristiano Ronaldo. I mean, think about it. He's one of the most observed humans on the entire planet. By this logic, his life should be constantly collapsing into negative states, but it just doesn't seem to. The source suggests that this isn't a bug in the theory, it's actually a feature.
The idea here is that some people might just be resistant. It's like their personal wave function is weighted in their favor. No matter how many times the dice are rolled, the probability of their good states coming up, it's just naturally fundamentally higher. And according to this theory, that resistance is the secret sauce. It's what lets someone not just survive, but thrive under that constant spotlight.
So we've gone from ancient folklore to the weirdness of quantum physics, and all the way back. Where does that leave us? What are we supposed to do with all this? Is this a description of reality, or is it just a really clever new way to think about an old idea?
All right, so let's just recap the big ideas here. First, you take an ancient belief, the evil eye, and look at it through the lens of modern quantum physics. Second, you frame a person's life not as a straight line, but as a wave function of possibilities. Third, you argue that massive amounts of observation, like fame, make it statistically more likely for bad things to happen. And finally, you have this idea that some people might just be resistant to that effect.
Look, at the end of the day, we have to be clear. This is not a proven scientific law. Not even close. It's a thought experiment, right? A really fascinating attempt to connect two totally different worlds. It's almost like a metaphor, using the language of physics to try and make sense of a deep-seated human intuition. And it leaves us with a pretty big question to chew on. Just how far can the rules of physics really go to explain the things we believe?